Hey, it's Jason. We're just going to go over a few review problems for Mr. C's exam, which will be coming up on, I think is in sometime this next week. This is just a public review session, so if anyone comes into the Discord, we'll just cover the questions there. If not, I will just pick a few questions from the different parts and just do them and explain my work. So I'm going to begin with, I'm going to say, let's see, which of these can I actually read and snip? I'm going to pull 7 from substitution rule, which is 5.5. Yeah, it's a little hard to read. So we're going to have u equal to x, I think it's squared, and then du equal to 2x dx. And then 1/2 du equals x dx. And this is for the function of x of sine of x squared dx. Oh, these are the answers. Okay, that'll be why. So, yeah, let's just erase that. And we can actually get rid of this since we don't need it. So we're going to have the integral of x sine x squared dx. We're going to want to set u equal to x squared, as this term right here has this to the second power, and then we're set du equal to 2x dx. Because we're taking the derivative, which will be 1/2 du equals x dx. So when we replace all the terms, we can take the 1/2 out to the front, as it is from the 1/2 du, and then it will be the sine of u du. From here, if we want to, we can just do the, this is a little trick I learned. So this way is derivatives, and this way is going to be for integrals. So we can just take the current position and follow it. So our sign will become an opposite cosine when we take the derivative. So we 1/2 cosine u du. No, actually we don't need the du because we don't do that. Alright, so that's opposite 1 over half. Then we're going to fill in for cosine of u. We're going to resubstitute that. And we're going to add it to c. And that is the answer. So for our next problem, we're going to do number, I believe it is 8, but it could be 9 from 5.5. It's a little hard to read because of the, it was photocopied. The question is for the integral of 1 minus 2x, all of that is squared, dx. So now we need to determine what our u is, which will be 1 minus 2x. Our d is going to be 2 dx, so 2 dx. And we're going to need to set that in terms of dx. That means opposite 1 over 2 du dx. Then we substitute. So we got the integral of u squared du, and we have the opposite 1 over 2, which we can bring out into the front. Then we integrate. And we add c. That will be opposite u3 over 6. And then we substitute back in for u. And 1 second, I think. I think I got the variable wrong. I think I misread. Okay, yeah, so this problem is slightly different. So this is supposed to be 9. But it's actually not to the second power. It is instead, this problem, I believe, is to the to the 9th power. So, what it's supposed to be, instead, being that this is technically a correct problem, it's just not the one that he asked. We're going to take the integral. We'll just do it again. 1 minus 2x to the 9th power dx. Again, we use the same U substitution as nothing has changed. So that will be from u to the 9th power times opposite 1 over 2 du. Of course, we can bring that opposite 1 over 2 into the front. And then we integrate. And we have c, which will mean it will be equal to opposite u to the 10 over 20 plus c, and then we resubstitute back in. And that is the correct answer. That is on the answer guide. Okay, let's go and take a bit harder one, which will be number 13 from 5.1. No, 5.5. So 13 is asking for the integral of dx over 5 minus 3x. So this is just going to be, we're going to be getting the natural log in the result. So our u is equal to 5 minus 3x. Our du equal opposite 3 dx, dx. And then we're going to want this in terms of dx. So it's going to be opposite 1 over 3 du equals dx. Then we simply substitute in. We're going to take this opposite 1 over 3 out to the front. Let me just erase it. And then because the integral of 1 over any value x dx is equal to ln of that value x, well, this will just be the opposite 1 over 3, or opposite 1 over 3 times ln of u, and then we substitute back in for u. And we want to make sure that we have the absolute value. Alright, and because this can all truly just be done in one step instead, so I would just say this is a tip to help speed things up. So if we notice here, we have this opposite 3, x. We don't really need to worry about this 5 here until we substitute back in. But because of this, we can just bring it directly out to the front. And then we know this whole thing, because it's only to the first power, is just going to be this. Then we take the ln of all the entire thing, and then plus c. It just makes it a little bit quicker. You don't need to have to do it all the time. So it's just 1 over the constant, which will be opposite 1/3, times then the whole numerator. Okay, let's see. I think we will going to pick. Is there a harder one here? Because I want to do one more 5.5, I just want it to be a little bit on the more challenging side. It's just going to take a second when it loads up. Okay, let's do 45 on the problem listed. So this is going to be the integral from 1 to 2 of x root x minus 1. So first we're going to need, and dx. First we're going to have to select a value for u. So we're going to do x minus 1, as it is the term that is overall larger. But this will also mean that x equals u minus 1, and we're going to need to have that. Our du is going to equal dx. So first we're going to want to substitute in. So this x right here, we're going to want to use u to the first, no, u minus 1 to substitute in for that. So it will be u minus 1, and then this is directly substitutable in for u, so for u, du. Okay, now we're going to want to put this in, we're going to want to distribute this u. Oh, and this is from, we'll just put it from alpha to beta. So when we distribute it, we get the integral from alpha to beta. Remember, this is u to the 1/2. So this will be u to the 3 over 2 minus u to the 1/2 all times du. From here, we can integrate. So we're going to get u to the 5 over 2 times 2, well, over, times 2 over 5 minus u to the 3 over 2. And then you just take the top term right there, put it underneath, and bring the other term out front. So 2/3 u to the 3 over 2. Oh, no, to the 3rd over 2nd power. And we're going to want this from alpha to beta. Then we're going to substitute back in for u, so 2 times x minus 1 to the 5 over 2 power divided by 5 minus 2 times x minus 1 to the 3 over 2 power divided by 3. All of this will be evaluated from 1 to 2. It's probably easier in this case to take it and just substitute in from a to b and find a and b. So let's just do that real quick. So if we're going to have 2 u to the over 5 minus 2 over 3, and that's also to the 5 2nd power. All that is going to be evaluated from, now let's find alpha and beta. So alpha of, what would that be? Oh yeah, alpha, so u of x is going to equal to the value of x minus 1. So u of 2 is going to equal to 2 minus 1, which is going to be equal to 1. And then u of 1 is going to equal to 1 minus 1, which equals 0. So this gives us the 1 over, from 1 and 0, which means as it's just the, everything's to this u power, makes it easier. Oh, hello! Someone else joined in the Discord, I didn't get a notification, so. I've just missed it. You've probably just heard me post and talking out loud, that's all I've been doing this entire time. Just trying to explain everything, so. So now we are going to evaluate it from 0 to 1. So I'm going to do 2 over 5, and then u to the 1 over 5 over 2, minus 2 over 3, 1 to the 3 over 2, minus, as u to any, 0 to any power is still 0, and this is 2 over 5 times 0 is 0, and same for the other thing, it's just going to be 0. So our final answer is going to be 2 over 5 minus 2 over 3. We could simplify this if we want by multiplying on this side everything by 3, so that will be 6. 6 over 15 minus, and then on this side we'll just multiply by everything over 5, 10 over 15, and we will get 4 over 15. Alright, I think we'll move on to sum of 6.2, which is integration by parts. Let's see. So we'll start with one of the easier ones, and then we will go on to a harder one. Let's begin with 1. So this will be 6.1. And our first problem will be the integral of x squared ln of x dx. So we're going to want to set a u, a du, a dv, and a v. And then I believe it's liate. So for logarithms, let me just re-look up the entire acronym. I don't remember the entire saying. So it's going to be logarithms, the inverses, the algebraic, trig, and exponential. So logarithms, algebraic, or no, not algebraic, inverse, and algebraic, then trigonometric, and then exponential. So we do have a logarithm right here, which I believe that means we will set that for our u, if I remember correctly. Actually, no, we'll set that to the dv, because then when we... wait 1 minute. Because, so the... no, yeah, we're going to want to set this to our u because it's easy to integrate. Or no, to take the derivative of. So ln of x. So that integrate, or when we take the derivative, we get 1 over x. And that means we're going to set x squared equal to dv, so x squared dx. And then when we integrate that, we get x to the 3rd power over 3. Alright, so from here, we're going to want to just go over and review quickly how we can integrate by parts. So the product rule states that, what is it? So from u, f of x times g of x equals prime of x gx plus g prime x fx. So then what we can do is we can shift one of these over to the other side. So we'll have fx gx minus g prime x fx. That equal to f prime x gx. So in this case, our g of x is going to equal u. Our dv, or no, and our f prime of x is going to be equal to x squared dx. Which is how we get these, I guess you can say, more simplified and neater way of writing it out. So if we get to take the integral of sorry. So if we take the integral of g of x times f prime x, that is equal to f of x times g prime x, oh no, g of x, minus f of x times g prime x, which gets even simplified when you put the u's in for everything. U dv equals u dv minus the integral of v dv. Alright, so from here, just select this real quick. And actually, let me just copy everything else also. We're going to want to bring down these U's and V's. So we're going to set this equal, let me just get my pen back out, to uv, so ln of x times x to the third power divided by 3 minus the integral v, which will be x squared over, no, x to the third over 3, du, which is 1 over x, and this is dx later. Let me just put that back. So we're just, so we're going to get ln of x times x cubed, no, x to the third power minus 3 minus, because we have an x3 there and an x on the bottom, we're going to have x to the second. We'll bring this 3 on out, so it'll be 1 over third, or 1 to the third power dx. So this will be equal to ln of x to the third over 3 minus 1 over 3, and then we'll take the integral. So this will be x to the third power divided by 3. C. As this is not a defined function, we need to have that c, and otherwise we'll forget it. Equals ln of x to the third power over 3 minus 1 over 9 x to the third plus. Alright, let's see. I guess let's go to a slightly harder problem. Let's see. Okay, let's go to number 11 in this section, which is the integral of arctangent times, I think that is, it's a little hard to read what it is actually to the, 4t. No, just wrote t twice. dt. So what we're going to want to do is again set v and no, u and d. So we're going to want to set u equal to our trigonometric right here. So it'll be tan inverse or arctangent of 4t. And that means we will set dv equals to dt. And that means the integral of dt is just going to be t. Now we're going to need the derivative of tangent inverse, which is equal. Oh, here, let me just put it over here. We're going to need to use the chain rule on this, because we have a term inside. So first what we're going to do, this is the f of g prime x times g of x, I believe. I don't remember the exact chain. 1 minute, we'll re-pull up the chain rule. No, this should just be g of x on the inside. And then it's times g prime of x. And f prime right there. And that will be equal. Wait. Oh, okay, I was just writing it initially wrong. So it should be f of g of x is equal to f prime of g of x times g prime of x. That's why I was confused now. I was mixing up this latter half with the prior half. So first we're going to take the derivative of tangent inverse, which equals 1 over 1 plus... Now we're going to have to, we're still keeping this 4t, so it's going to be 4t squared times, and then we need the derivative of 4t, which will just be 4. So that is going to equal 1 over 1 plus 16t squared, and that's going to be times 4. And then, as this is the derivative, we want to make sure we have our dt there. Alright, then we're going to go to u times v minus the integral of v times du. And that's going to be to the dt. Alright, so we're going to be able to pull that 4 out to the front. We're going to have tangent inverse of 4t times t minus 4 times the integral of t over 16t squared times dt. So we're going to have to use U substitution to finish up solving this one. So we're going to set u equal to, well, actually we'll use w, just because we already have used u and v. So we're going to set w equal to 1 plus 16t squared. That means our dw is going to equal 32 times t dt. And then as our term, as we have t dt, we're going to have to do 1 over 32 dw equals t dt. Then we substitute on in the tangent inverse of 4t times t minus 4 times the integral of 1 over 32 dw over w. We get to call this the 1 over 32. Times the integral of dw over d. Then we got arctangent, or tangent inverse, of 4t times t minus, we will simplify that up. So that will be 1 over 8 times the integral. So we're going to just integrate that real quick, which will be ln of w. And we're going to have to, again, have plus c. Then we'll just neaten everything up a little bit and resubstitute back in. So we're going to have tangent of 4t times t minus 1 over 8 of ln of absolute value of 1 and then let me just check that answer real quick. So that's t arctan of 4t minus 1 over 8 ln 1 plus 16t squared plus c. Perfect. Alright, I guess let's do one more of the 6.1 for this. Let's do number 17. So for 17, we have the integral from 0 to 1/2 of x cosine of pi x dx. So we're going to want to set our u du, v dv up again. And we still want to, it's just easier to write that. And we will write our substitution real quick. So I believe Mr. C wanted us to write the integral of u times dv equals u times v minus the integral of v du, just so that we can we don't make mistakes and we can memorize that. So I guess I should really kind of do that. So our first thing is to look for what we have. So we do not have any logarithms. We do not have any inverses. We do have an x and we have a trig. And actually, that's not an E, that's supposed to be an E for exponential. So I believe we'll just pick the cosine of pi x to be our u, and we'll just set x dx to be our dv. So we will integrate that real quick. So it'll be the integral of x, so that'll be x squared over 2. And then we want to take our derivative of cosine of pi x. So sine, cosine, opposite sine, opposite cosine. We only want to do derivatives. So from cosine, when we take the derivative of cosine of pi x, it's going to be opposite sine pi x times pi. For the chain rule. So we have opposite pi sine of pi x. And then just get that dx in there. Alright, so this integral from 0 to 1/2 is going to be equal to well, let's just integrate first and then we'll go back and evaluate. So it is going to be equal to cosine of pi x times x squared over 2 minus the integral of v, so x squared over 2 times du, to be opposite pi sine of pi x dx. So we're going to take constants out of the integral, and we're just going to leave this as x squared cosine x over 2 minus. So our constants for this are going to be an opposite pi and divided by 1/2. So this will become positive pi over 2 times the integral of x squared sine of pi x dx. Alright, let's see. I believe we can use actually no, we're going to have to go and redo this again. So we're going to have to do another integration by parts. I was trying to see if we could have used U substitution, but we can't because we have this x squared on the outside times the dx. If it was an x on the outside, it would have made it a bit easier if the x squared was on the inside. Also, hello to the other person who joined in on the Discord. So what we're going to want to do is we're going to want to set our u du, and then our dv times v, and d and v. We'll just rewrite the rule once again. And for this, we're going to, as we want to follow what we did before, so we're going to set our u equal to sine of pi x. And our dv is going to be equal to x squared. So that'll be x to the third over 3. And I just realized I think I should have been done switched to up that I put down. But it's a little late. I mean, I guess we can go through one more time, and if I messed up, then we can just go back to the other part. So we're going to just take the integral of the derivative of sine pi x. So we're going to pi cosine of pi x dx, which we can get through the chain rule, again using this up here as a little cheat sheet for derivative integrals. Equal to x squared cosine pi x over 2 plus pi over 2 times, now we're going to want to set this integral equal to u dv equals uv minus the integral of v du. So it's going to be u, so sine of pi x times x over 3 minus the integral of v du. Let me just move this over to the side. And I do think I actually messed up, because this is just going to keep increasing one time each time. And this should eventually have equaled out to the initial equation. So I'll just go through this one thing, but I do think I messed up there, as otherwise it's just going to keep looping back and keep increasing each time. Yeah. So what should have been equal, it's just going to keep increasing, so we're going to need to redo this. I messed up. So let me just copy this and we'll go back. Luckily, the good thing is that if you do mess up like I just did, it is plenty of easy to see, as you're not going to get anywhere. It's just going to keep going up and up. And we are on 17 still. So we're going to let u equal x this time, dx, and we're going to let dv equal to cosine of pi x, and v equal to, well, we're going to have to take the integral real quick. So the integral of cosine of pi x dx, so that is going to be 1 over pi, there's a constant of sine x, or no, sine of pi x. So then we'll have 1 over pi sine of pi x. And without this, and you can get this through U substitution. I'm just skipping over the U substitution. So now we're going to have the integral of u dv equals u times v minus the integral of v du. So this will be u, this will be dv. So we're going to have u, so x times 1 over pi sine of pi x minus the integral of v du, which will be 1 over pi sine of pi x times cosine, times dx. It's just misreading and saw the dv. So from here we're going to get x sine of pi, and this will bring the 1 over pi out to the front. The integral of sine pi x dx. So from here we can use U substitution. So we're going to set w, well actually we can do this in our head, but w equals dw equal pi dx, dw over pi is going to equal dx. So we can just simply substitute in. And then we're going to substitute this in, so dw over pi. And then we're going to take that pi up to the front. And from here we will integrate. So the integral of sine as integration is this way is going to be opposite cosine. Then we will substitute our w back in. X sine of pi times x. That over pi minus 1 over pi squared. And we can actually bring this minus out, so plus times cosine of pi x plus c. And that will be our final answer for this problem. Actually, no, it's not, because we have to evaluate from 0 to 1/2. So again, let's rewrite this for evaluation. Which just means we drop the c and have the evaluate from 0 to 1/2. Alright, so we'll begin by inputting 1/2. I have 1 over 2 sine of pi times 1 over 2 over pi plus 1 over pi squared times cosine of pi times 1 over 2. We're all going to be subtracted from, well, 0 times sine pi x over 0, over pi is going to be 0. And then that's going to be plus 1 over pi squared cosine of pi times 0 . Oh yeah, no, I want that. Alright, then let's simplify and find the sine and cosine. So this is going to be equal to 1/2. No, actually we'll put sine pi over 2 over 2 pi plus 1 over pi squared cosine of pi over 2. And then we'll distribute this minus, so minus 1 over pi squared cosine of 0. Simplify once more, so sine of pi over 2 is going to be equal to 1. So 1 over pi over 2 pi plus 1 over pi squared. Cosine of pi over 2 is 0, so that cancels out. Minus 1 over pi squared. Then cosine of 0 is equal to 1. So our final answer should be 1 over 2 pi minus 1 over pi squared. And I am just checking because I got a different answer apparently than... Oh, no, that's correct. So if you want to, you can get common denominators. So we multiply by pi and pi there. So it'll be pi over 2 pi squared minus 1 over pi squared will then equal pi minus 1. Oh, you actually have to multiply this by 2 on top and bottom. So 2 over 2 pi squared, and that will be 2. So this is, you can use, I'm assuming he'll allow this, but if not, common denominator for this one is pretty simple. Just going to multiply there and there by 2. And got to multiply this by pi over pi. Okay, let's see. Is there, I guess we can probably do one more problem. let's do one from 6.2. Hello. Also, if anyone has any problems, just say so in the chat, and then we can just do them. We can probably do one or two more, as we got around 13 minutes left before I need to head out. If not, we will just do some of the, 6.2 is Trigonometric Identities, so we can always give one of those a try, as those have been, honestly, a bit of a pain, I think, for all of us. If we have one of them on the record, then we can at least allow people to go back and check those out. So, this will be, 6.1, we're just going to do number 1. Let me get that. It will be the integral of sine squared times cosine of cosine to the third power x dx. So our identity for sine squared cosine squared equals 1. So we're going to turn our cosine squared into 1 minus sine squared, and we can do that as cosine squared x equals 1 minus sine squared. So we simply first begin by rewriting. So we'll have sine of 2x times 1 minus sine 2x times cosine x dx. So now we're going to distribute and do U substitution. So we're going to our U equal, so first we'll do U substitution. So first we're going to set U equal to sine x, du equal to cosine x dx. So we get the integral of U squared times 1 minus U squared times du. From there, we want to distribute the U squared. So it'll be U squared minus U to the 4th du. And then we want to integrate this. So this is going to equal the integral of U squared du minus the integral of U to the 4 du. So it's equal U to the 3 over 3 minus U to the 5 over 5 c. We want to now substitute our value back in for U, which will be sine x. So sine 3x. Now sine to the third power times x over 3 minus sine to the 5th power of x over 5 c. Yeah, and that is the correct answer for that. I guess we can also do one other part from 6.2. So let's go on to number 3. So number 3 is the integral from pi over 2 of sine 7 theta times cosine of 5 theta times d theta. So to begin, we're going to want to identify what we want to use our U. So I'm going to set U sine of 7 theta. Or no, it's not sine of 7 theta. That might be a lot. Just sine of theta. And du equal to cosine theta d theta. So what we're going to want to do is turn a majority of that cosine of 5 theta into sines. So cosine squared theta equals 1 minus squared theta. So we're going to get sine of 7 theta times 1 minus sine squared theta. And this is you can either rewrite it again or you can square it as it's multiplying it by itself. Times cosine theta d theta. Now we want to insert our u's. So we're going to have the integral of u to the 2nd power times 1 minus u squared to the 2nd power du. So now we need to expand this. So this will be u to the 7 times 1 minus 2u squared plus u to the 4th. Now we want to distribute our u to the 7th. So u to the 7th minus 2u to the 9th plus u to the 7, 8, 9, 10, 11. Then we want to integrate. So we get u to the 8th over 8 minus 2 over 10 u to the 10th power plus u to the 12th power divided by 12. And of course you want to probably add alpha and beta just as fill-ins there, but we'll find indefinite first. Or yeah. Then we'll just fill in our u's. So u is equal to sine of theta. We have sine of 8 theta over 8 minus 1 over 5 of sine to the 10th theta. No, 2 sine to the 10 times theta plus 1 over 12 times sine to the 12th power of theta. Let's see, and then we're going to want to re-put back in our evaluation. So it'll be sine 8 theta over 8 1 5 12 times sine 12 theta. I believe our range is, or no, our values is from 0 to pi over 2. Then we're going to want to insert our values. So sine of pi over 2 is just going to be equal to 1, and 1 to the 8th power is going to be 1. So it'll be 1 over 8 minus 1 over 5th plus 1 over 12 minus, and sine to the 0 power is 0. So all of these to the 0th, when theta equals 0, will equal 0. So we'll just put that there. 1 over 8 minus 1 over 5, 1 over 12. And then we could simplify this if we wish. We can either try finding the least common denominator, which I would take 8 times 5 is to 40. And we can get, I believe, to 40 from, well, at least let's do this. So we're going to multiply, this will be 5 eighths, no, 5 times over 40, because you have to multiply by 5 on both parts, minus 8 over 40, over 12. So this will be opposite 3 over 40, plus 1 over 12. Then we can take, we'll do 40 times 12, or actually, let me just, so we're going to take 40 multiple, or we're going to take 3 times 12. The common denominator is going to be 380. There's probably in the lower number, but this is just the easiest. We can simplify after. So 3 times 12 is going to be 36. Opposite 36 over 480 plus, and then we're going to take 12 and we're going to take 1 times 40 and then 12 times 40. So it'll be 40 over 480, and this will equal out 40 minus 36 is going to be 4 over 300, no, and 480, which will equal 1 over 120, which is our answer to this problem. Alright, I think I'm going to call it this for tonight. I'll probably do another review session again. Hopefully I will not make the same mistake like I did last time, which took forever. Alright, I am going to stop the recording.